Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. I'm Miss McGuire, and today we're going to be studying the quadratic formula. Today's lesson is Unit 3, Lesson 9. Don't forget to put your first and last name, the period, and the date at the top right-hand corner of the paper. And our objective today is I will solve degree 2 polynomials by using the quadratic formula. Before we use the quadratic formula, though, it does involve a square root or a radical. So we need to practice simplifying radicals before we start using the quadratic formula. So for example 1, part A, we are going to simplify the square root of 4. Now, hopefully this is a review of what you learned in Algebra 1 last year. But when you simplify radicals, what you're really doing is looking for a group of numbers that are the same under the radical. Now, when I talk about a square root, there's technically a 2 as our index. There's a 2 right there. So when I find the square root of something, I'm looking for a group of 2 numbers that are the same under the radical. So to do that, we break down 4 into its prime factors. So 4 is really 2 times 2. Well, hey, there's a group of 2 numbers that are the same. So what we do is we take that number, that's a group of 2, we bring it out in front. So we bring out a 2. We bring out the number that represents that group of 2. And we put it in front of the radical. Well, if we bring out those 2's, then what's left in the radical is technically a 1. There's technically a 1 here. Well, what's the square root of 1? 1. So this is really just 2 times 1, or 2. And that is why the square root of 4 is 2. All right, now let's do the square root of 100. So break 100 down into prime factors. Well, 100 is what? 25 times 4. 25 is 5 times 5. 4 is 2 times 2. Well, hey, I've got a group of 2 5s and I've got a group of 2 2s. So I'm going to bring out a 5 and a 2 out in front of the radical. And this, we keep things as multiplication when we simplify radicals. So it's really 2 times 5. And then there's nothing left inside the radical except for a 1 technically. But again, the square root of 1 is just 1, so we don't really need it. Then what's 2 times 5? 10. All right, what about the square root of 200? So we're going to break 200 down into prime factors. Well, isn't 200 really 2 times 100? And 100 is 2 times 10 times 10. Well, check it out. I don't even have to break 10 and 10 down even farther because I've already got a group of 2 numbers that are the same. So let's bring a 10 out in front of the radical. And then this time, what's left in the radical is a 2. So we leave that under the radical. So the square root of 200 simplifies to 10 times the square root of 2, or 10 root 2. Why don't you give part D a shot on your own? So the square root of 32. Break 32 down under the radical into prime factors, and then bring out groups of 2 out in front of the radical, and then leave anything left underneath the radical. Go ahead and press pause and then press play when you're ready to check your work. So as you can see, I broke 32 down to 2 times 16. I broke 16 down even farther, so I have 2 times 4 times 4. I've got a group of 2 4s, so I bring that 4 out in front of the radical, and my answer is 4 times root 2. All right, part E, the negative of square root 72. So because there's a negative out in front of the radical, we just leave it in front of the radical the whole time, because that just means -1 times the square root of 72. So then we still break down what's under the radical into its prime factors. So 72 is what? 2 times 36. Then I can break 36 down even farther to 6 times 6. And hey, I've got a group of 2 numbers that are the same. So I'm going to bring that 6 out in front of the radical. So this is technically going to be -1 times 6 times the square root of 2. Now what's -1 times 6? -6 root 2. Now, why don't you go ahead and try one on your own? So part F, the negative times the square root of 512, or you could say negative root 512. Go ahead and break 512 down into its prime factors and simplify the radical from there. So as you can see, I broke down 512 to 2 times 256. I kept that negative out in front of my radical at every step as well. And then I just kept dividing by 2. So then I got 2 times 2 times 128, 2 times 2 times 2 times 64, et cetera, until I broke it down to 2 times 2 times 2 times 2 times 2 times 4 times 4. Well, then I found a group of 2 2s, a group of 2 2s, and a group of 2 4s. I brought out a 2, a 2, and a 4. So I've got negative 2 times 2 times 4 times root 2, or negative 16 root 2. All right, let's do another one. The square root of 147. Go ahead and break that down into its prime factors. Bring out what you can in front of the radical. Leave what's left under the radical. Give it a shot on your own. Press pause and then press play when you're ready to check your work. So I broke down 147 to 3 times 49. 49 is 7 times 7. So we have 7 root 3 as our final answer, because we had a group of 2 7s that we can bring out, and then we leave 3 under the radical. And last but not least, let's do problem H, 3,375. Break it down into its prime factors, and then bring out the groups of 2 that you can and leave what's left under the radical. Go ahead and press pause and press play when you're ready to check your work. So I broke 3,375 down to 25 times 135. 25 is 5 times 5. 135 is 5 times 27. And then I just continue to break those down. 3 times 9, and then 9 became 3 times 3. So I've got two groups of 2, a group of 2 5s, a group of 2 3s. I brought those out in front. And then I was left with a 5 and a 3 inside the radical. 5 and 3. 3 times 5 is 15. 5 times 3 is 15. So we got 15 root 15 as our final answer. All right, let's dive right into the quadratic formula. This is seriously one of my favorite things in Algebra 2 ever, which is pretty cool. So the quadratic formula is a formula that we use to find our x-intercepts, or also known as our zeros. So we use it to find our x-intercepts and zeros. And when we use it is when normally when we use it is when a problem can't be factored or it looks like it's too difficult to factor. So use it when you can't solve by factoring. So the quadratic formula is just another method to solve for zeros. Just like when we learned the week before Thanksgiving break that you can solve quadratic functions by factoring. So there are some quadratic functions that can't be factored. And so instead of factoring, we use the quadratic formula. So the quadratic formula is as follows. First of all, you need to make sure that you always put x equals out in front of it. This is something I'm really picky about. If you don't have this x equals in front of your formula, I'm not giving you credit for it. X is equal to, your x values are equal to the following formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we use this to find the x values of our x-intercepts, or our zeros, for a function. So a couple things I need to point out, though, that I'm super picky about. Not only do you need to make sure you always have x equals out in front, especially with every single step of simplifying this, but you also need to make sure that this division sign, our fraction bar, goes all the way across under the negative b all the way to the past the root symbol, the square root symbol. All right, so it starts right after the equal sign, includes the negative b. You're dividing this whole side by 2a. Then you also need to make sure that this square root bar extends all the way across and includes all of b squared minus 4ac. And you want to make sure that happens as we show our work as well. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, remember, a quadratic function is in the form of y equals ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is your constant. So you're just plugging those values in. A is the coefficient of x squared, b is the coefficient of x, and c is your constant. So you're literally taking a, b, and c from y equals ax squared plus bx plus c, and then plugging those values into the quadratic formula, simplifying, and then you've got your x values for your x-intercepts. So let's use it. So example 2, part A, our equation is 4 equals 2x squared minus x. Well, remember, what do we need every quadratic function to be equal to before we can solve it? That's right, it has to be equal to 0. So we're going to subtract 4 to both sides. 4 minus 4 is 0, equals 2x squared minus x minus 4. So this is the equation that we're going to use. Our a value is the coefficient of x squared, so that would be 2. Our b value is the coefficient of x, so in this case it's negative 1. And our c, our constant, is negative 4. So we're going to plug those values in for a, b, and c into our quadratic formula. So remember, the quadratic formula is x equals the negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, let's plug these in. So the negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times 2 times negative 4. And then all over 2 times 2. So see, I took my a value and I plugged it in here and here. I took b, I plugged it in here. And I took c and I plugged it in here. Now we need to simplify this thing. So let's do it. I'm actually going to draw a line down the middle here and show my work going down off to the left side first, and then I'll come up to the right side if I need more room. So simplify it. X is equal to the negative of negative 1 is positive 1, plus or minus the square root of negative 1 squared is 1. Negative 4 times 2 times negative 4 is what? Negative 8 times negative 8 is 64. No, wait, what did I just say? Negative 4 times 2 is negative 8, and negative 8 times negative 4 is 32, because I can multiply. All over 2 times 2, which is 4. So x is equal to 1 plus or minus the square root of 1 plus 32 would be 33, all over 4. Now there's a couple things I need you to notice. One is that my square root sign goes all the way across, 1 plus 32. My fraction bar here goes all the way under the 1 and then past the square root sign. And I have x equals at each step. Now we need to see if we can simplify our radical. So on the next step, I'm going to do x is equal to 1 plus or minus 33 can be broken down to 3 times 11. Those are both prime. It can't be factored down any further. So we know that the square root of 33 is the simplified version of that radical. All right, so now one thing I need you to understand is that this is actually two answers. This plus or minus is actually two separate solutions. So x is equal to 1 plus root 33 over 4, and x is equal to 1 minus root 33 over 4. So when you write your final answers as zeros, you can either write them together like this, or you can separate them. So when I write my zeros, I'm going to say x is equal to 1 plus root 33 over 4, comma 1 minus root 33 over 4. Or if you want, like I said, you can write your zeros like this. X is equal to 1 plus or minus root 33 over 4. As long as you understand that that represents two solutions. Whichever one makes more sense to you is perfectly fine. Then our x-intercepts, again, you can write them separately or together. So for my x-intercepts, I'm going to have 1 plus root 33 over 4, 0, and then 1 minus root 33 over 4, 0. And those are my x-intercepts. Or, like I said, you can write your x-intercepts like this. 1 plus or minus root 33 over 4. 0. As long as you understand that that represents two different x-intercepts. So write whichever one makes the most sense to you. All right, so why don't you try one on your own and see how far you can get without me. So for part B, you're going to do 0 equals x squared plus 4x minus 3. First, identify A, B, and C, and then plug those values into the quadratic formula. If I were you, I would draw a line down the middle here and then start working off to the left, work down, and then if you need to, come up and work down on that right side as well. All right, give it a shot. See what you can do without me. Press pause and then press play when you're ready to check your work. All right, so you probably got at least this far, where you identified A as 1, B as 4, C as -3. When you plugged it in, it should say x equals the negative of 4 plus or minus the square root of 4 squared minus 4 times 1 times -3, all over 2 times 1. Then as you simplify that, you should have x equals -4 plus or minus the square root of 16 plus 12, all over 2. 16 plus 12 simplifies to 28. But the square root of 28 can be simplified further. So we're not done yet. You're going to have -4 plus or minus the square root of 4 times 7, all over 2. Then 4 can be broken down even further because 4 is a perfect square. So I'm going to come back up here. X is equal to -4 plus or minus the square root of 2 times 7, all over 2. So as you can see, we have a group of two 2's that we can bring out in front of the radical. So this becomes x is equal to -4 plus or minus 2 root 7 over 2. But we're actually still not done because this whole thing is being divided by 2, which means this -4 is being divided by 2, and so is the 2 over the 2 root 7. So we need to simplify that because -4 is divisible by 2, and so is 2. So let me show you what this really means. So what this really means is that x is equal to -4 over 2 plus or minus 2 root 7 over 2. Well, -4 over 2 becomes -2. -2 root 7 over 2 is just root 7. So that is the most simplified that this number or the solution can get. So our zeros are x is equal to -2 plus or minus root 7. Then our x-intercepts are -2 plus or minus root 7, 0. And you can split them like we did in the first example if that makes more sense to you. But I'm going to leave them like that because I don't want to write two answers. Okay, so there we go. So now let's try one more on your own. This example is 2x squared minus 3x minus 7. Identify A, B, and C, plug them into your quadratic formula, and see how far you can get on your own. So press pause and then press play when you're ready to check your work. So I plugged in -3 for B, 2 for A, and -7 for C. As I simplified, I got x equals 3 plus or minus the square root of 9 plus 56 all over 4. 9 plus 56 simplifies to 65 under the radical. Then I broke 65 down to 15 times 5, or 13 times 5, which can't be broken down any further. Those are prime factors. That radical can't be simplified because there aren't any groups of 2. So we know that we're done when we get to there. Now we also know that we're done because 3 over 4 can't be simplified, and root 65 over 4 can't be simplified. Now, I just want to point out that you could rewrite this as x equals 3 over 4 plus or minus root 65 over 4 as well. But there's no need to write it like that because there's nothing to simplify. So now write your answer as zeros and x-intercepts. So my zeros would be, let me zoom out. My zeros would be x equals 3 plus or minus root 65 all over 4. My x-intercepts would be 3 plus or minus root 65 over 4. Now, next semester when we get into graphing these problems, we will change these to a decimal so we know actually where to graph, because off the top of your head, do you know where 3 plus root 65 over 4 would be on the x-axis? I don't off the top of my head. So surely you don't either. I don't know, maybe you do. But when we start graphing, we'll change these to decimals and then graph the decimal version of this number. But for now, you leave it as a fraction and a radical in your final answer. You never want to give me a decimal for your final answer for these. You always want to give me the simplified radical and fraction form. All right. So in 0 equals x squared plus 8x plus 12, I want you to go ahead and get started on this problem without me. A lot of things are going to end up simplifying though, but I want to see how far you can get without me, and then press pause, see how far you can get, and then press play when you're ready to check your work / see how simplified we can take this. So go ahead and do that. I'll see you in a minute. All right, so when you plugged A, B, and C into the quadratic formula, you should have the negative of 8. I should have put 8 in parentheses here. The negative of 8 plus or minus 8 squared minus 4 times 1 times 12 all over 2 times 1. Then x is equal to negative 8 plus or minus the square root. 8 squared is 64. Negative 4 times 1 times 12 is negative 48. 64 minus 48 is 16. The square root of 16 is 4. So we end up with x equals negative 8 plus or minus 4 all over 2. But notice, negative 8 is divisible by 2, and so is 4. So this can be simplified further. So we need to simplify this all the way. So x is equal to negative 8 over 2 plus or minus 4 over 2. Well, negative 8 over 2 is negative 4. 4 over 2 is 2. Now, because we have integers, we can actually do the addition and the subtraction. So this is really x equals negative 4 plus 2 and x equals negative 4 minus 2. So we get x equals negative 2 and x equals negative 6. Then, of course, we have to write our answers as zeros because your teacher is really picky for some reason. X equals negative 2 and negative 6. And then we also have to write our answers as x-intercepts, negative 2, 0, and negative 6, 0. All right. Now let's talk about one more. So something tricky happens with this, but again, let's see how far you can get without me. So press pause and then press play when you're ready to check your work. Go ahead and plug this equation into the quadratic formula. So hopefully you were able to at least get this far, and you noticed that A was 1, B was 4, and C was 5. So you plugged in 1 for A, 4 for B, and 5 for C into the quadratic formula. When you simplify what's under the radical, 4 squared becomes 16. Negative 4 times 1 times 5 is negative 20. Well, then 16 minus 20 is negative 4. We have a negative under the radical. We haven't really gone over in Algebra 2 yet what to do with a negative when it's under a radical. But what we have talked about before is that when this happens, that means that you have an imaginary solution. And after the break, after winter break, actually, at the start of semester 2, we're actually going to learn about imaginary numbers and imaginary solutions. But for now, all you need to tell me is that there is no real solution. And you know this because there's a negative under the radical. And as of right now, we're not going to simplify a negative under a radical. All right, so go ahead and do your extra practice, and I'll see you back in class. Have a great day.